Hi grade 7s. Well, by now you've looked at the video about properties of numbers and you've seen that the order in which we do certain sums often does not change the answer. So in certain cases we can change the order of the numbers in a sum but still get to the same answer. Now I'm going to show you in this activity why that is so handy to know. So I'm going to help you with all of these sums. Some of them are easy, like 17 times 1, which is just 17. All right. This one says 7 over 0. So I want to remind you that that sign there is simply a little divide sum actually, with a dot there and a dot there. So this is 7 divided by 0. Division by 0 is not allowed. You can watch on YouTube, there's loads of extremely complicated reasons why and so on. But what you need to know is that anything divided by 0 is always, the answer would always be called undefined. Even your calculator will tell you, error, please stop trying, this doesn't work. But the other way around, 0 divided by 7 is fine. Let's think of these two sums. Let's compare them in a way that your primary school teachers we would say, I've got 7 sweets. I divide them by nobody. I mean, what does that even mean? But at 2.3, if we say, I've got no sweets. I divide them by 7 people. How many sweets does each person get? Well, then clearly everyone just gets no sweets. So when you say 0 divided by something, it simply stays 0. So that's not an undefined answer. Okay, when I look at these, this is a little bit of inverse. If you think of, well, if 74 plus 37, they don't even ask you for the answer. Many of these sums have nice little shortcuts. They don't want the answer. They just want to know 74 plus 37 will be the same thing as 37 plus 74. So that's very simple. The same here. I know that 9 times 6 will be the same as 6 times 9. So that's just to show that the order of addition and the order of multiplication does not matter. And as you learned in the video, the order in which we minus does matter. And the order in which we divide does matter. Okay, this one is also quite simple, but what I'd like you to start looking at now is shortcuts. Guys, we're going to make this as easy as possible, and these sums, even though they look big, have to kind of turn out to be mental maths for you right now. No need for long multiplication here. We're going to chop and change them a little until they're very easy to do. So you know your bonds from like previous grades, you learned your bonds often. So when I look at all of these, the first thing I want to say is that I see a 6 and a 4. I love putting 6 and 4s together. That gives me 10, right? So why don't I start by firstly adding 74 to 26? Because now I know, okay, 7 plus 2 is 9. So that's going to be 90. And the 6 plus the 4 gives me a 10. So immediately I can see 90 plus 10 is 100. So 74 plus 26 is 100. That wasn't so difficult to figure out mentally. Hey, but look at this. Now the sum reads 100 plus 37. And this side doesn't ask for the answer. It just asks 100 plus what will be the same as on the left? Oh, it's 100 plus 37. Cool, hey? And so always look for little numbers that match, like these two bonds. That kind of gives me a clue that I'd like to go and plus those two together first before bothering the 37. And so at 2.7, we're now going to look at the order in which we multiply. If I'm going to do this, and I have to work it out step by step, I'm going to do 2 times 2 is 4, and then I'm going to do 4 times 7, and that's going to give me 28, and then I have to work out 28 times 25, which your teacher can't do in her head. So then it takes you to long multiplication, which we're trying to avoid best we can. So here's a nice little shortcut. Look at this. 2 times 2 is 4, right? So why don't we swap the order? Remember, we can swap the order of multiplication. Why don't we just say 4 times 25 times 7? Now, why would I do that? Because 4 times 25 is very easy. 4 times 25 is 100. right? You know 4 25s make 100. So I end up with 100 times 7. Is that mental maths? Yay! There we go. So just by moving the numbers around, I could make it much easier to solve. Having to do 28 times 25 would have still given me 700, but it would have been more difficult for me to get to that 700. I would have still gotten that same answer, but the sum would just not have been so easy. So do you see why I move them around? Look at this one. 2.8. If I look at 8 and 125. Now, I hope you guys remember this from grade 6, because I went on and on and on about you having to know this one big timetable. 8 times 125 is 1,000. That's one I'd like you to memorize, remember. So that's one I know out of my head. 8 times 125 is 1,000. So if I do those two first, I'm left with the very easy sum of 1,000 times 19. Now guys, isn't that easier than working out what 8 times 19 is, which I don't even know. I'll have to first go break it up. And then doing that answer times 125. That would have taken me much longer. This is mental calculation. I write a 19 with 3 zeros. At 2.9, I'm again going to look for a bit of a shortcut, and actually it slots in with this one. You'll see it has very much the same numbers, except for now it doesn't have the 8. It has a 2 and a 4. But 2 times 4 is anyway 8. So you know what? This is going to work out to be exactly the same as the previous one, because I'm going to do 2 times 4 is 8 firstly. Then I'm going to times the 8 by the 125, which you'll know will give me 1,000, and then I'll times it by 19. So I'll again end up with 1,000 times 19 being 19,000. 2.10. Now I want you to focus on, you'll see the next two are both written in this way. There's a times and a plus, and then a times. You, according to Botmas, must do timesing before you do plussing. That means I must firstly work out that time sum answer and plus it to that one. But guys, 27 times 36 is difficult. That's one I'll have to use long multiplication for. Now you go and you look for similarities. I'm seeing a 27 here and a 27 there. So that means I'm going to times 27 by 36, and then I'll go again and times it by 64. So here's the trick. You're just going to go and times it by one big number. Now what's that one big number going to be? It's going to have to be the sum of these two. Sum means plus. So you're going to have to plus those two. But look how nicely they plus. Do you see the bonds again? Here's 6, here's 4. 6 plus 4 is 10. So, and 30 plus 60 is 90. So this is a 90 plus a 10. Wow, it's 100. I love it, because now it's 2700. I'm going to do one like this again. Do you see a times, a minus, and a times? Botmas tells me that I need to do my timesing before I do my minusing. So I'm grouping it this way. 37 times 45 is not an easy one to work out, but I start looking for similarities and I find 37 in both of them. Now in each case, 37 is being multiplied by a different number here and there. But now we must look carefully. In the end, I'm going to minus these two answers from each other. So what's the use in timesing 37 by 45 if in a moment from now I'm going to times it by 44 and then take that away? I'm going to minus that from my answer, so I'm going to make it much less. So the trick now is to say I'm going to times 37 by one big number. How am I going to get this one big number now? I'm going to say, well, what is 45? Now I'm not going to plus them because it wasn't a plus like previously. I'm going to minus them because there's a minus there. What is 45 minus 44? It's 1. So instead of going and finding one big number and subtracting another big number from it, I'm just going to cut straight to the chase and say, well, instead of doing it 45 times and then doing it 44 times less, I'm just going to do this once, because 45 minus 44 is 1. And this gives me 37. One more, we're going to leave the last two out, so let's just check this one out. If I look at 2.12, I see, I guess there's different ways to look at it, but what I see is that this is 99 times 99, and I'll have to do that part first. Quite difficult. If I go and take 99 and rather write it as 99 times 1, right? That still gives me 99. Look what that makes of the sum. That means I can go and take 99 as my factor that they have in common. And then I can say, all right, I was going to times it by 99, but then I was also going to times it by 1. And I need to plus those two. Do you see the little plus in the middle? So 99 plus 1 is 100. So I might just as well go and times it by 100. And that again makes it a mental math sum. So now I don't need a calculator or long multiplication for this. Then, guys, you'll see in your assignment that you're going to leave out 3.1 to 3.6 for now. Those are long multiplying, and it looks like long multiplication and division and addition. But in fact, there's also the possibility of looking for shortcuts. But let's skip that and go to 3.7, which is what you also have to do for homework. It says here, and this is very importantly, this gives you all the information you need. And again, there's no working out in these sums. All you have to do is rearrange the numbers with inverse operations. So I'm going to write down something very quickly just to remind you. As you know, 5 times 2 equals 10, right? So if I look at the inverse fact family now, then there's a few ways I could write this. I could say 10, I could just write it in reverse. 10 divided by 2 gives me 5. Do you see I'm using the exact same 3 digits or numbers? Or I could say, well, 10 divided by 5 will give me 2. Okay, so do you remember with inverse that we can rearrange the numbers but use the exact same numbers, and this sum works in exactly the same way. The numbers are just a little bigger. So if I have this big number and I want to divide it by the 36, then my answer must obviously be the remaining number. That's very easy. If I have this number divided by the 473, which is there, then that's my remaining number. The 36 is then what's left. Right, so the next sum looks different. It doesn't have the same digits, but since it's part of this fact family and it's here, I had to look a little closer and see, well, how is it related to this family? And then I realized, but 18 would be what I get when I say 36 halved. Right, so I'm dividing 36 by 2, that gives me 18. And that gave me a clue. So then I also looked at what I would get when I double 473. And I noticed that 473 times 2 is 946. That's good news. So now, this means I took this number. Let's rearrange this quickly. I just want to show you what this can do. In other words, if I break this up, I can break it up and say 473 times 2 times 36 divide by 2, right? But remember we said we can rearrange these because the order in which we multiply doesn't matter. So let's just quickly rearrange these a little. If I then write it as 473 times 36 times 2 divide by 2. Now you might notice what actually is happening here. Why would I go and times something by 2 if straight after it I'm going to divide by 2? Can you see that these cancel out now? And voila, if they cancel out, I'm going to end up with the exact same question. So when I'm looking for my answer now, I realize, well, if I'm doubling the one and halving the other one, those two things cancel each other out, and so I will end up with exactly the same answer, 17028. Cool, hey? Okay, let's look at inverse with our addition and subtraction. Again, no working out, guys. All you have to do is look at this fact family, and I'll do a quick reminder of inverse when it comes to plus and minus, but I'll use easier examples. So if we say 8 plus 2 equals 10, for example, then you guys know very easily 10 minus 2 will be 8, or 10 minus 8 will be 2, right? So they're all the same. So when I do 118 minus 71, I'll obviously get the 47 as the answer, or if I do the 180 minus the 47, I'll get the 71. I didn't have to even work that out. Right, guys, so just to confirm, that was me helping you with most of the work for the day. What I've not done for you is 1.1 to 1.5. You still have to go complete that by yourself, please. I have helped you with 2.1 till 2.12, and I've also helped you with 3.7 and 3.8. Right, all the best.